Welcome to EEL 512, Electronic Circuit Analysis. Chapter 2, Electronic Circuit Analysis, Silicon Controller Rectifier, SCR, Application. Part 2, Evaluate SCR applications in power electronic circuits. Analyze SCR circuit, half-wave SCR with our load. Let's start with SCR circuit operation. As was observed earlier, diode rectifiers produce a fixed output voltage. To control the output voltage of a rectifier, phase control thyristors must be used instead of diodes. Also known as a phase-controlled rectifier. The output voltages of these rectifiers are varied by varying the delay or firing angle of the thyristor. There are two types of converters, half-wave and full-wave. An SCR behaves differently from a regular diode. Even when it is forward biased, it will not start conducting on its own. For conduction to begin, two conditions must be met. First, it must be in a forward bias state. Second, a gate trigger pulse must be applied. This gate signal acts like a switch to start conduction. Here is a basic circuit setup of a half-wave controlled rectifier using an SCR with a purely resistive load. We'll use this as our reference example to understand its operation during positive and negative half cycles of the AC input. Let's look at the operation cycle. During a positive half cycle, the SCR is forward biased but remains off until we apply a gate pulse. Once triggered, it latches on and keeps conducting until the current falls below the holding current, which happens near the zero crossing point. During the negative half cycle, the SCR is reverse biased and blocks the current entirely, meaning no conduction occurs. These are the waveforms for our circuit. The input voltage is sinusoidal. The output voltage and current waveforms depend on when we trigger the SCR within the positive half cycle. The thyristor current follows the load current during conduction. This PSIM simulation shows the relationship between all these parameters in time. Finally, to calculate the average output voltage, we use this equation. Here, V sub m is the peak input voltage, and alpha is the firing angle, the point in the cycle when the SCR is triggered. The integral from alpha to pi represents conduction over the remainder of the positive half cycle. Thank you, and see you in the next video.